in the reading, you know how it gave you that like link to go and look at the different histograms and stuff?
Mm-hmm.
That page is amazing. So many colors.
The graph's not showing up. None of the graphs.
Did you hit the begin button?
Yeah. I'm at the screen, but none of the graphs are showing up. Like all the numbers on the side are, but you know, hard to explain.
Mine's working.
Well, aren't you special?
You can work off mine. We'll work together like a group or something.
Okay.
All right. When taking samples of... Oh, wait. Did you guys do 1 and 2?
I did.
No. I did false.
I think I got it this time.
Good. As long as they're false, we're good. When taking samples of n, when n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
That was in the lesson 2 video, I believe it was.
Yeah.
I believe it's skewed right because it doesn't change anything with the small.
Because the parent is right skewed.
Yeah, if it's a small sample population though, it doesn't change anything until it gets larger.
What was the scale of being small? Because I know once it hit 25, that was a large sample, obviously. But like, what was the differential? Because on the thing it goes 2, 5, 10, 16, 20, and then 25.
20?
30. For most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to ensure
Okay, so that's large.
X bar will be approximately normally distributed. So.
Okay, so 2 and 5 are small. Would you consider 10 being small?
Yeah.
Yeah.
What about 16? That's what I can't tell. Because it's a little more than 15, obviously.
Mm-hmm.
So it's more than half of 30 being large, so...
Mm-hmm.
I don't know. We'll get there when we get there.
Okay.
Okay, so when taking samples of n equaling 100, then it would be normal. Because you have a huge sample size.
Do we all agree on this one? Have we read it through thoroughly?
Oh wait, when the parent population is right skewed. So if it's right skewed with a sample of 100...
It'd be skewed left, wouldn't it?
No, it should still be normal because of the large sample.
But the parent population in 5 is normally distributed. Maybe if my graph was working, I'd figure it out.
That one has a parent population that's not normal, correct? For tremendously skewed distributions, I'm going to read the section from when it talks about the X bar being normal. For tremendously skewed distributions, a much larger sample will be required before the distribution of sample means is approximately normal. This may require billions of observations. Simulation can be used to determine if a particular sample size is sufficient. For this course, if the sample size is at least 30, we will conclude that the sampling distribution of X bar will be approximately normal.
I mean, it's in the reading.
And he shows this on like the video tutorials as well. He takes that like a right skewed graph, and he goes through and does it with small sample sizes of 5, and it stays right skewed. And then he does it with a large sample size, and it goes back to the normal distribution.
Because the more samples you have, the smaller the what is it called? The divisions.
The standard deviation.
Those are the things. It decreases them, so you're not going to get a huge skew.
Yeah.
Just going to stay close.
Okay.
Isn't that sigma over u or something?
Sigma over the square root of the sample size.
Square root of sample, that's what it is. So,
number 5, when taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed?
it'll still be normal, correct? Because regardless of if it's normally distributed or right skewed or left skewed, if it's a large enough sample, it's going to stay normal, correct?
Okay, where is this distribution of means histogram thing? I want to pull this up so I don't make sure I'm not giving you any information that's wrong.
Look at the next paragraph that comes in. It gives like mean and standard deviation of the distribution of the mean.
Mm-hmm. I do not see this. Is it in the part where I asked you like the sample question? Is it in the solution?
Are you looking in the reading or?
Yeah, in the reading.
It was right under where you just read. It's number 3. If that's what you're looking for. Ahead.
Yeah, because the two ways that it can be normally distributed is with a sample size that's large or a sample drawn from a normal population. So it would be normal. Because the population is normally distributed. So it's going to leave it as a normal.
It makes sense.
Where was that found?
Number 3 is the mean and standard deviation. It's right above that in the like the question that they give you.
Oh.
The answer to that.
There are 2 ways that X can be approximately normally distributed. Oh, okay.
Does that make sense?
Makes more sense when you explained it.
I mean, it doesn't say anything necessarily about being right skewed or whatever, but it does distributed if those 2 things are happening or one of them is.
All I know is if it's a large sample, it's going to be normal no matter what.
Right. I remember reading it, but I don't remember where. So.
There's so much in these chapter things, it's hard to say.
I try to like mark up and note as much as I can, but not so good. All right, should we move to 6?
Oh.
Do it.
Because we can always come back if we feel that we need to.
We'll do it when we come recheck.
Yeah. Okay, so when would the distribution of means be normally distributed? Okay. Data is drawn from a population that is normally. No, that's not the first one. Data is drawn from a population that is normally distributed and the sample size is large. It's the second one. And I don't know about the rest of them. I just know the second one's true. So data is drawn from a population that is normally distributed and the sample size is large. That's what I just read to you guys. But I don't know if that's all of them. I know that's just one of them.
I just know it's 2 and 4.
You think it's 2 and 4?
I mean, pretty much answer 4 is what we just put for question number 5.
That's true. If it's right skewed, the sample size is large.
Yeah, whatever that was.
Okay. That makes sense to what we put down.
What do you think?
So that's what I'm wondering, because I know that it talks about the distributions being approximately normal, so I would assume that with a large sample size it would be considered normal as well, even if it's right skewed. So I would say it is 2 and 4, personally.
Do we think it could be anything else?
No, because the other ones are going to be messed up, and with a small sample, you're not going to get anything corrected.
Because that's when everything's going to get all like the standard deviation is going to get bigger.
What's the difference between a heavily skewed and like a right skewed or a large or a left skewed? Could it be like a heavily right skewed?
Like I think just heavily skewed means it's skewed in general. Then you have your specific left or right skews. Wait, what about number 1 then? Because if we're saying number 4, then we would also have to say number 1. Because if it's based on only one of those principles alone, then the top one's still going to stay normal, even if it's a small sample size. It won't change anything.
Shoot. Well, let's go to the little graph thing and press on the buttons.
Let's do it.
Small sample size. Okay, small sample. I guess you would be right. It's still normal.
So if we animate 1,000 of the small samples, it's still normal.
So yeah, put n equals 2 and then put 10,000.
Yeah, that's what I did. And then if you do, let's try right skewed. Is it right skewed or left skewed, does it say? Right.
You just put skewed? Or can you actually change that?
Yeah, if you click and drag on the top part, you can change it.
Oh, yeah. Whoopsies.
Then if we go down there, we'll say, and then the sample population was large. So we'll go to 25. I think it's the largest we have.
Yeah, then hit 10,000.
Do 10,000 on that one.
Normal.
It's normal. So it'd be 1, 2, and 4.
I can agree based on the charts we just looked at.
Okay. I mean, I agree too. I did it, but
Because just with the two requirements that you have to have a normal parent population or a large sample size, and 1 and 4 have one or the other, but based on those graphs, they still both come out normal. And then, of course, number 2 has both, so it's going to be normal no matter what. There's no reason why it shouldn't be. There's just not a large sample size to correct the skew. And
oh, that's the key. Good point. Okay, yeah. So it's the size of the sample which will bring it back to normal.
Yeah.
And if it's small and normal, obviously it's still normal. If it's large and normal, it's going to stay normal because it's so large. But if you don't have enough sample and it's right skewed, it's going to stay right skewed because it can't bring it back to equal.
Exactly.
Okay, cool. That makes more sense.
So I think that helped us out with our earlier questions too, like 3, 4, and 5.
Yeah, so let's review those real quick.
Okay.
If that's cool with you guys. I don't
Yeah,
wanna
I'm totally down.
So when taking samples of n equals 5, so we have a small sample and it's right skewed, it's going to stay right skewed. So
yeah.
then 4, we have samples of 100, and it says in our reading anything above 30 is the large sample size. So it's going to be normal. Even if it's right skewed, it's going to be brought back. And 5, same thing. If it's normal, it's already normal, and the sample's huge. So I'm feeling pretty good about 1 through 6 right now.
Okay.
Okay, and what gives the best explanation of the central limit theorem? Let's see. The central limit theorem states that if a sample size is large, the sample mean will be approximately normally distributed. So D?
It could be C or D, because it also says that the sample mean X will be close to the mean.
Okay.
So.
No, the third one's going to be your law of large numbers.
Oh yeah, that's true.
So they're similar, but
which
that's
one's more accurate?
You're right. It's D. It's D.
I just saw it on the homework. I just remember it from there.
Yeah, and yeah. Okay. So let X be a random variable with the population mean equaling 10 and the population standard deviation equaling 6. Suppose a sample of the size n is drawn from the population. What is the mean of the distribution of sample means? That's confusing to read. Okay, so it would be.
Is this the one where it's sigma over sample squared?
Yeah. So it'd be 6 divided by the square root of 36?
Yeah.
So it'd
6
be
divided
1.
by 6, essentially being 1.
It'd just be 1. That you guys got?
6 divided by
In my
6.
head. Yes.
Man, guys, catch up.
I wish I had the cool graphing calculator. I got one, so
That lights up, and it does like different colors and stuff too. It's awesome.
that's intense.
Number 9, what is the standard deviation of the distribution of sample means?
Okay, so this one obviously is going to be a little different. What do we take for this equation?
Oh, whoa, wait. Did I just do that right? I thought that equation is for the standard deviation.
Okay, no, I think we're wrong.
I think we did it backwards.
Yeah, we did. Just like we did on that last question from last homework. Or group.
But it does say 3 decimal places, and so 1 doesn't have 3 decimal places.
Okay, so what are the equations we learned?
Deviation 6. There's a standard deviation over the square root of the sample of mean, the sample, and
Okay, so it talks about in that third number 3, mean and standard deviation of the distribution of sample means. It says the mean of the sample means is mu. So that answer to the first one should be mu. Because it wants to know the mean of the distribution.
Yeah.
That should be 10.
Okay, because that's going back. I was like, wait a minute, we don't have to do anything for this.
And then
right.
the
But for 9, it's just 1, but there's no decimal places.
1.000. Just kidding.
Yeah, you do that and tell me how it goes.
Yeah. Submit. I was wrong.
Deviation of the sample means is the distribution divided by the square root of the sample size.
Yeah.
So square root of 36. It should be 1.
It's just 1. I'm leaving it.
Is this a trick question?
Right?
Yo, teacher, if you're watching this portion, I don't know if you skip around or watch it. Is it 1? What's going on?
Okay.
And 3 decimal places, so 1.000.
I'm scared to put
We'll come back to
1.000.
Okay, we'll do it right now because that's the equation, right? Like sigma divided by the sample.
Yeah.
Distribution of sample mean is a distribution of all possible sample means x bar, which is our mean, which happens to be. Would that wait? Hang on, let me try 10. This is gonna sound real dumb. I'm gonna try it. See, if you do 10 divided by the root 36, it gives you 1.66667.
But that's not the equation.
That's what I'm confused about.
It isn't the mean over the sample. It's I'm leaving it because that's the equation we were given.
And we haven't been given anything else, so
I'm putting that. It's the only thing I can think of.
And if it's wrong, I'll be really surprised because that's only ruining our education.
It doesn't make sense if we only have one equation to figure it out and it's wrong.
You have to use.
I mean, unless we're putting like 0.000, like you said.
So 8 is 10, and then 9 is 1.000.
Agreed.
All right, we'll hold on to that for right now. Okay, number 10. Regardless of the distribution of the population, if the sample size is large, so it's larger than 30, what would be the shape of the distribution from the sample mean? It'd be normal. Because anything, what was it? If you scroll down to the summary,
Yeah, it's normal no matter what.
Yeah, it says in bold, for this course, if n is greater than 30, we will say the distribution of the sample mean is approximately normal, even if the parent population is not normal.
And then 11 would be the central limit theorem because that's exactly what it is.
Yeah, that was one of the answers earlier, just a second ago.
I mean, that's what it says. Central limit theorem guarantees the distribution.
Yeah.
Okay, so we're going back. We're good through 1 through 6, obviously. 10 and 11 are good. 7's fine, so we're back at 8 and 9.
8, we're leaving. It is 10.
And duh. So 9.
So who wants to put the 000? I think it should just be 1. I don't think there's a decimal. Because,
If
I mean,
anything
there
else,
is a decimal in the sample that they gave us in the reading, which is like 8, what was it, like 0.2, 0.2 in our, like, just in the reading for that question. But there's no decimals with 1, so I think I'm going to leave it.
Hold on, I'm gonna get my calculator and double check something real quick.
This is like the only time I second guess myself, and it could be right.
So I'm looking at, in that section in the book, they give a sample problem. I'm gonna double check the sample problem, make sure we're plugging in the numbers correctly. And if that's a thing, then we should have the same answer.
You're doing the one that was with the 8.7 minutes and all that?
Yes, that one. So,
Yeah, so it was
Because that's
like
the one I just did,
0.2.
plugged it in, and it's right. Like everything we just did is correct.
2.2 divided by the square root of 121 is 0.2.
6 divided by 36 squared is just 1.
Exactly.
Yeah, I got the same exact answers they got in the book, doing it the same formula, plugging in the same things that we did for ours.
But why would he add 3 decimal places?
Maybe to scare you.
Psych you out.
Doing a good job. He wins this round.
Maybe exactly for the reason you tested, to see if the other one would give you decimals and be like, oh, this one has decimals, we have to use the mean instead of the deviation.
Dude, he's ruining my life, one question at a time.
I think it would be really, really stupid if he wants 3 zeros after it. But I don't think he does, because it's not a decimal at all.
What is the same deviation? 3 decimal places. Okay. He threw that in there for no reason.
I think it might be a scare tactic. I'm gonna do this real quick.
The only one that's freaking me out.
Well, it's stupid because it's 1.
It is 1. There's nothing else it could be with that.
Why couldn't you use, like, the sample's 37, and then it'd be, like, okay, easy? He's going to be like, why is this video 30 minutes long? It should have been, like, 10. And then they'll find the last 2/3 was us trying to figure out why we have to put in 3 decimals and not miss, like, 2 points. Okay, if we put 3 decimal points as 1.000, it's still technically 1, so the answer would be right, correct?
Mm-hmm.
Yeah.
So...
But I'm feeling like I'd get marked off if we do that.
But it says 3 decimal places. Oh, stupid.
We should have this teacher on speed dial.
Just straight text him and be like, what does this parentheses 3 decimal places mean? Or we'll just email him and be like, alright, it's obviously 1 with 3 decimal places for whatever reason. And that's it.
Yeah.
Because the answer's right either which way, but it's what the test is going to accept. I went first last time. Okay, do we all think it needs decimal places?
No. I don't. I think he's trying to psych us out.
I do. I think because 1.000 is still 1. Like
It is still 1. Maybe the test grades it that way. I don't know. I guess we could do it.
Like computer generated, and they're looking for a specific set of numbers. That's
The answer is 1.000. Hit submit. Trust me. I just did it. A+.
1.000?
000 is the answer.
That is so stupid.
He
I
tried
knew
to.
it had to be that easy. I was like, I'm not going to argue with you guys. You guys know, and I know, we all know it's 1.
Either way, it's 1. It doesn't. Oh my heck.
Hey, Brooke, you should have tried just 1 to see if it would have taken.
We should have made Brooke. Give in to the pressure, Brooke.
I would have argued with him and just said, look, I was just trying to see if it would mess up the system or not.
All right, cool. Well, that
Nice
wasn't
job,
bad.
guys.
It wasn't as bad as we thought.
No, I think as long as we keep helping each other understand how these concepts work, we should be fine throughout the semester. But this
That,
is
make sure we're prepared, too, before our meetings.
yeah. I got
It helps.
Is the homework the bigger chunk? Oh, you can probably turn off the live feed since we're done.
Oh, yeah.
Good job, guys.